Here's a problem from 12.6 that deals with independent events. In this particular problem, let's read it. It says if 80% of scheduled flights actually take place and cancellations are independent events, what is the probability that 3 separate flights will take place? So this particular problem, although the word "and" is not explicitly used, we do want to realize that this is what is the probability that one flight and another flight and another flight will take place. So it actually does involve the word "and." And our "and" formula would be the probability of A and B is given by the probability of A times the probability of B. So because we're given that the probability of a flight taking place is 80%, we're going to represent that with 0.8. And then we mentioned that to find the probability that 3 flights would take place, that would be the probability of the first taking place and the second and the third all taking place. So if we use this formula, now we would also have to involve another event since there are 3. So that would be the probability of the first taking place times the probability of the second times the probability of the third. And because they are independent events, they're each going to have that probability of 80% that they would take off, because one taking off does not affect the probability of the other. So for each one of those, we would represent the probability as 0.8. And then when we multiply 0.8 times 0.8 times 0.8, we get 0.512. And then depending on whether you're asked to represent the probability as a decimal or a percent, and how many places you would want to round, I'm going to actually convert this to a percentage. That would be a 51.2% chance of that the 3 separate flights would take place. And that could also have been represented as a decimal if you were asked for that and rounded to a different decimal place if you needed to.